Hi guys, don't forget to subscribe my channel and like this video. Okay, enjoy! Hi guys, so these are few examples from tutorial which you can refer to answer other questions. In question number 1, you need to name the compound based on the IUPAC system. For question number 1b, the parent name will be based on the benzene group. When the benzene group attached with the methyl group, it can be named as toluene. Then bromine will act as substituents. Bromine are located at carbon number 2, 4, and 6. So we can name the compound as 2,4,6 tribromo toluene. Why tri? Tri means it consists 3 bromine atoms. For question number 1c, since the straight chain of carbon got more carbon compared than the cyclic compound, so then the parent name will be named based on the acyclic compound. So first, we must identify the longest chain of carbon from this compound. So the longest carbon will be 1, 2, 3, 4, 5, 6, 7, and 8. Why I didn't start count carbon number 1 from here? This is because when I start from here, the number of substituent will give the highest number. Then based on the 8 carbon, the parent name can be named as octane. At carbon number 3, we've got cyclopropyl, and carbon number 4, we've got iodo. Then we can name the compound as 3-cyclopropyl 4-iodo. Why I put cyclopropyl first instead of iodo? This is because we need to follow the alphabetical rules C and I. For question number 2, you must draw the compound based on the name given. For this type of question, you must draw the parent group first. Usually, the parent group are located at the end of the name. So for this compound, the parent group will be 5-decene 1-ene, which means it consists double bond and triple bond. So decene means this compound contains 10 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. At carbon number 1 contain triple bond, and carbon number 5, 1, 2, 3, 4, 5 consists double bond. Then we look into the substituents. At carbon number 3, you got 1, 2, 3, got iodo, and carbon number 5, iodo, and carbon number 4, 1, 2, 3, 4, got isopropyl. So this is the compound for this question. Next, we look into the question number 3. Predict the product or products of the following nucleophilic substitution. For this type of question, first thing you need to do is to look into the type of nucleophile, either weak or strong nucleophile, as different nucleophiles produce different type of substitution reaction. For question number 3b, the compound reacts with water, which is the weak nucleophile. That means the compound will undergo the SN1 reaction. In SN1 reaction, the hydride shift between beta carbon and alpha carbon could be happen in the reaction to achieve the more stable carbocation. Thus, the product will give more than one product. The alpha carbon will be at carbon attached with halogen, and beta carbon will be adjacent of alpha carbon. Then, if you can see here, alpha carbon is secondary carbon. Meanwhile, beta carbon at this carbon is tertiary carbon. So then, when this compound react with water in the substitution reaction, OH will substitute bromine at this carbon. Then you will get one product like this. Next, since the adjacent alpha carbon are more stable, the hydride shift will happen. The OH will attach at this carbon. Then you will get the product like this. Between these two products, the second product will be the major product due to the stability of the product. Next, I will explain about the mechanism for this reaction. As I said before, this reaction go through SN1 reaction. It means it involves more than one step. In other words, it involves the formation of carbocation as intermediate product. First step, the bromine will leave the compound as a leaving group. Bond between carbon and bromine will be given to bromine. It will produce bromide ion and carbocation as intermediate product. If you can see from this carbocation, the hydride shift will happen between alpha carbon and beta carbon, since this carbon could give more stable carbocation. Hydride shift means hydrogen from this carbon will shift to the alpha carbon and give the positive charge at this carbon since it loses electrons. Next, water as nucleophile will attack carbocation. One lone pair in oxygen from water will attack the carbocation and it will form another intermediate product. Oxygen will be positive charge since it loses electrons. Last step is bromide ion will take one hydrogen from O and H, and bond between O and H will be given to the oxygen as it will neutralize the positive charge of oxygen. Then you will get the final product. In question 3D, the compound reacts with methoxide ion. If you revise on the slide chapter, you will see that methoxide ion is strong nucleophile, which means this reaction will go through SN2 reaction. The SN2 will not involve the formation of carbocation. In other words, no hydride shift happen despite the adjacent carbon can give more stable carbocation. Simply answering this question, it only produces one product when it goes through SN2 reaction. The methoxide ion will substitute chlorine at this carbon. Then you will get the product like this. As I said before, this reaction goes through SN2 mechanism. It means it only involves one step mechanism. In the mechanism, chlorine will leave as leaving group. Bond between carbon and chlorine will be given to chlorine. At the same time, methoxide ion will attack the carbocation from back of the structure to produce the final product. Then you will get the final product. Question 5 is an example in predicting the product or products when haloalkane go through elimination reaction. Same as previous question, you must identify the type of nucleophile that been used in the reaction, since it will affect the type of reaction, either E1 or E2. In question 5C, methanol is the weak nucleophile, which means the haloalkane will go through E1 mechanism. In other words, the carbocation will form in the mechanism and hydride shift might happen in the reaction to achieve more stable carbocation. At first, you need to identify alpha carbon and beta hydrogen. For this compound, alpha carbon will be carbon that attach with halogen and beta carbon will be the adjacent of alpha carbon. These two carbons. At beta carbon must have beta hydrogen. In the elimination reaction, as chlorine leave as leaving group and it make this carbon become positive charge. Then methanol will take beta carbon and bond between beta carbon and beta hydrogen will be given to the alpha carbon, as it will form double bond between alpha and beta carbon. For this case, it will give two different products since it has two different beta hydrogen. As I said before, this is E1 elimination. In the mechanism, carbocation will form and hydride shift might happen to achieve stable carbocation. If you refer to this compound, first carbocation will be formed at this carbon after chlorine leave as leaving group. This carbon is secondary carbon, and if you see the adjacent carbon, it can give more stable carbocation since it was tertiary carbon. Thus, hydride shift will occur and then you will get another carbocation. Next step will be same as the previous step. After new carbocation form, identify beta hydrogen. Then, make the double bond between alpha and beta carbon as beta hydrogen being eliminated. Then you will get the product for this reaction. Next, you need to identify which one the major product among these products. By following ZF rules, the compound that give more alkyl groups that attach in C double bond C will be the major product. Let's check one by one. First product, it only has one alkyl group attached to C double bond C. Second product, it gives 3 alkyl groups that attach to the C double bond C. Meanwhile, for the third group, it gives 4 alkyl groups that attach to C double bond C. It means the third product will be the major product for this reaction. About the mechanism, you just need to show the mechanism in producing major product. It starts with chlorine leave the compound and then it forms carbocation. Hydride shift occur between this carbon and the adjacent carbon since the adjacent carbon is the tertiary carbon and could give more stable carbocation. Hydrogen will shift to this carbon and give new carbocation. Next, methanol will take hydrogen from this carbon as bond between the carbon and hydrogen will be given to the positive carbon and it will form double bond. Then you will get the final product.